Okay, so basically, we have a situation here where we have two locations. The first one being myself, as Zero Tango Papa November in Rafina, Athens. And let's say we want to talk by VHF radio to somebody that's located in Crete, which is a fictitious call sign of Sierra Victor 9XXXX. Now, if you look at this, you can understand by Google Earth. A simple ruler will tell you that that's over 300 kilometers away. Now, to talk about VHF radio that distance, it's a little tricky. There are ways that you can do it, and there are situations that make it possible. Specifically, you have exotic propagation modes, as they say. Sporadic E, thermospheric ducting, auroral propagation, meteor scatter, Earth, Moon, Earth. And it's actually Earth, Moon, Earth is the worst, well, the most difficult one to do because it requires very specialized equipment, heavy-duty equipment, because you're trying to bounce off the moon. But the most common one is sporadic E propagation. And that does happen by bouncing off of the E layer of the ionosphere, just basically kind of like what high-frequency HF radio does. You can bounce off of the ionosphere, but sporadic E propagation doesn't occur very often, and it is seasonal. So during the summer, you very rarely will have any sporadic E. So once again, to look at this situation, you want to go from Athens, Greece, for all practical purposes, to Crete, over a little over 300 kilometers. It's a little bit difficult. Now, technically, the optical horizon for a VHF radio is approximately 7 to 10 miles, but you can have something further than the optical horizon, about 15% more. It's non-line of sight, but you do get some scattering of the VHF radio energy, and you can go beyond optical, but typically 15 miles is point to point at sea level is nominal, is the normal thing. So we're going to try something a little different now. So here we have this. We're going to switch subjects now, keeping in mind we're trying to talk long distance, and we're going to talk about ADSB data. ADSB is basically a system used by aircraft to communicate with ground stations, and basically ADSB is an automatic dependent surveillance broadcast. So what that does is all aircraft have, especially commercial aircraft, will have an ADSB transponder, and that transponder is exactly what it sounds like a transponder does. It sends a beacon to the ground station that contains information about the aircraft. Its heading, its call sign, its what the transponder within the aircraft is set to. In other words, it's a 4-digit identifier for purposes of air traffic control, the aircraft, as well as other things, heading, altitude. It carries a broad range of different information. It's encoded digitally, and it's sent from the aircraft down on a frequency of about 1 gigahertz. So one thing we can do is we can actually see that on a site called Flight Radar. Here's an example of a site that captures that ADSB data, and it uses that to put a map of all the airplanes. Here's an example, all the airplanes in Europe. It's actually captured all that. So you have all these airplanes in Europe, and it's capturing the ADSB data and displaying it. And you can go and you can see what's landing at Athens Airport here. All these airplanes are queued up to go to Athens Airport. And you can click on one and you can find out that example. This aircraft is an Airbus 310. It is flying from Heraclion to Athens. It tells you its altitude. It tells you the airspeed. It tells you a lot of information about the aircraft. Its squawk code, which is code that the aircraft uses to help air traffic control keep track of it. And it's all the information is there. You have the registration number. That's all there. And that information is being derived from ASDB data, which is being captured and placed on this website. But we can do something. We have an SDR radio, software-defined radio, little box, basically, that's software-defined. And that radio is, in this case, it's called an AirPlay radio. It's a very small box, fairly expensive, like 140 euro. And this is what it looks like on the left. That's an SDR Play box. It's a software-defined radio that is capable from 0 hertz all the way up to 2 gigahertz of reception. And with it, we're going to try to hear this ADSB data or decode it. I mean, hearing it doesn't say anything for the human ear because it's all digital, but we're going to try to decode the signal that we'll receive from that. And to do that, we'll use this disc cone antenna. Disc cone stands for disc and cone antenna. You can see the cone is pointed downwards with those elements pointing down, and the disc is the outward elements going out 90 degrees. And this actually does have a small antenna on the top as well. So this SDR Play, software-defined radio has software that comes with it. The software we're going to use, I'm going to go ahead and activate the software right now. In this case, it's called, the software is called Uno. It's called SDR Uno. So I'm going to go ahead and start that software up. SDR Uno is starting. It's going to, you'll see a host of windows that will pop up. So here it is. Here's the host of windows that pop up for SDR Uno, showing a spectrum, shows the frequency we're using. A lot of data. There's a lot of data here on this. So basically, this is very interesting because you could, in theory, well, not in theory, in actuality, we can go ahead and we hit the play button to start this, to start the software that runs the radio, because the radio is plugged in by USB to this computer. We hit play, and we can hear the ASDB data, which is 1092 megahertz, 1 gigahertz. But this is what it sounds like. Not very appealing at all. Doesn't sound very nice. But it is what it is. Okay, so like I said, there's nothing here. It's digital, so it's just a squalor, actually. Nothing much to listen to. But what we can do now is we can come over to the software. Now that's running and it's receiving the frequency of the ADSB. We can come up to plugins, which you have to load. Once you load the software, you can load the plugins. And we can click on the ASDB plugin and say load plugin. And once we do that, we get a window. That window is the plugin, ADSB plugin, that comes with the software that is connected to the receiver. There's the plugin, the ASDB plugin. We go ahead and we can hit start, and right away we can see that we are actually reading aircraft information. Here's the flight numbers. It's showing us flight numbers. It's showing us speed. It's showing us heading. All of this. So right now, what we've managed to do is with the antenna, with the SDR Play box, which is on the far left, connected to the computer. That's actually what powers it. And it has you can see the antenna connection that goes outside to this antenna, which is in the middle. So with those two items, we're able to get a decoding of all the aircraft in the region. Now, there's a program, as an example, to see this, to better visualize it. There is a software that is called, Virtual Radar. And what Virtual Radar does is it will take that ADSB data and it will go ahead and make it available to us to plot it on the screen. So, like we said before, we have data that is available to us, meaning we have the software, the web page, which we looked at before, which is the flight radar, which is from a commercial site that does this. But now, if we come to our software and we open up a program called uh, virtual radar. Virtual radar, the window of which is this. Here it is. There's our virtual radar window. The virtual radar is software that we've installed on the computer that is taking the information that is coming from the SDR program, and it's going to plot it on a map for us. And this is it. This is the ADSB data that we are capturing directly from the software via the plugin. Via this plugin, it's this data that we're receiving via our antenna that's connected to the software-defined radio, the small SDR Play software-defined radio, using the software that is used to run that radio, which is an SDR Uno, with the ASDB plugin. We've got all this ASDB information, and that information now can be plotted on a graph. Each ring is 50 kilometers. So it gives you an idea that we can go out almost 400 kilometers and get ADSB information from aircraft. And the reason we can go that far out is because the aircraft tends to be very high. As an example, we click on this one here, and we can see that this is an Airbus 320. It's an Airbus 320, and it is located right now 11,000 meters high. So we have a very clear line of sight to that, and we can see also that it's going. We can see where it's going, and we can see its call sign and everything. We can see it's a twin jet land plane. Its distance from us is 140 kilometers. Its speed is 425 knots. It's heading 136. All this information is coming from the SDR Play box, the receiver, the SDR Play box, connected to its software, which is the SDR Uno, and the software has the ASDB decoder, which is the plugin that you install on the software to give us this information. So now we have this information. So let's get back to our question of how are we going to talk to our friend in Crete, barring meteor storms and e-propagation and bouncing things off. And how can we just simply use a VHF radio to talk to this gentleman? Well, there's a software called, it just came, well, it's been around for a while. It's called AirScout. Now, what that does is it takes the ADSB information. It takes the two locations, meaning us in Rafina and the other gentleman land next to Athens, land on the land in Greece, and then the island of Kanya, island of Crete, specifically Kanya, and it allows us to draw a line between those two locations. And we can see that this is roughly 300 meters. There's the first point, and there's the second point. So we have the 2 points. And what happens is it will show us, because it's getting the ADSB information constantly from our software-defined radio, from the SDR on its software. It's getting this information. It's showing us the aircraft that will pass between 2 points. Now, that happens when we start that software. We have to input certain information. Specifically, we have to input right here on the chart. Right up here on the side. We know we'll be on the 144 megahertz band. The first location is me. That's my locator. The second location is the fictitious location of Sierra Victor 9XXX in Crete, and we can give him we'll give him a location in Crete. We'll put a temporary location there just for purposes of this demonstration. We'll put in a location KM 15UP and save that and start the software. And here you go. It shows us the first location in Rafina. The second location is the fictitious call sign, but in Crete. And it's showing us aircraft that are going to pass across us, our path. So now we know that we have certain aircraft that are going to pass between those two locations that are roughly 300 kilometers apart. Now, since we have a rotator, and that rotator is this far right, or actually this picture here will show you the rotator. That's an antenna, VHF antenna on a rotator. This software is capable of controlling the rotator. So what's going to happen now is, if, as an example, if I click on the aircraft that's going to pass between us, like this aircraft here, I can see that this aircraft is an Airbus 320 Neo. And we can see that it's passing along, and that the rotator says here I have to turn my rotator to 180 degrees. Now in my rotator software, if I go ahead and I set the rotator software to start tracking, which I'm going to do right now, I'm just bringing it up so you can see it. When we go ahead and on the rotator software, I will go ahead and tell it to start tracking by selecting this button. And this software is called PS Rotator. This is the software that controls the rotator. And it also has to be set up. In this case, it is. It's set up to read information from the AirScout. And that information can be seen on the setup folders and the setup areas. But in either case, it's there. So what we can do now is we can see that our azimuth, what we need for an azimuth and elevation, is present there. We're going to go ahead and tell the software, go into tracking mode that you can see right there. You select tracking. And we select tracking mode. Now that we've selected tracking mode, the antenna will turn towards the, it will turn in accordance with the information given by the software to track that aircraft. See right here? To track that aircraft. Right there, we're tracking that aircraft. The antenna is actually turning and tracking that aircraft right now. Almost 180 degrees. And we can see the controller software showing you that it's almost there. Now we are literally pointing at that aircraft. Now, if we transmit with our VHF radio, we will be basically using the air scatter off that aircraft that is between myself, my station, and the remote station in Crete. We can both target that location and work off of what they refer to as air scatter. And here's a software, the AirScout software. There's more information about how the AirScout software works. It shows basically, there's a yellow line here showing what angle the station in Crete needs to be at to see the aircraft, and what angle I need to be at, which is the red line. And this magenta area is the area showing where we could work, where we actually could work with both stations, and it shows you the dots there. It shows you that in this current situation, since it's right between both it's between both, right now this specific aircraft is actually right between both our locations. So it's perfect. And you can see that on this graph. On this graph, this chart, and it shows the two locations, the two stations. It shows that the aircraft is right between both. And if we both aimed at that location, which is 150, maybe 170 kilometers away from each party, that by each station, we could use it as a air scatter to communicate on the VHF band. Now this software, I can pause the software temporarily here. And there are other things that are shown here, specifically spectrum and other analysis. This software, specifically the AirScout software, is actually quite impressive. It does a lot, quite a bit. So not only does it show you this aircraft that we were tracking, it shows you, example, here's another aircraft coming in. We'll go ahead to the aircraft that we're using before. We're going to go ahead to this aircraft here. It's going to turn, not only is it going to show us on this aircraft as an example, which we know to be an Airbus 321neo. We can see that aircraft, its location as it comes between the 2 points in between us. We can see that. But also, it automatically will coordinate the turning of the rotators, so the antennas are pointing at that aircraft, elevation and azimuth, and it shows us this graphical chart of the magenta area where we could theoretically communicate. I mean, example, the pass of this aircraft will work for both stations across that whole magenta line. So, but it does something else that I find really very impressive. I'm going to start the software by hitting the pause button. And I'm going to go to options within the software. In the options, it gives us station information. So here's the first station, that's me, and here's the second station, the station in Crete. But for myself, I can actually go here and I can click on radio horizon. And this will show me, I can calculate my radio horizon to the other station. This shows me how far it's calculating based upon obstructions on the horizon, what my radio horizon is exactly. And you can see, as an example, how because I have Imito, because I have the mountain of Imitos in that region to my northwest, there's a dead space here because of mountains. But south, that's all open ocean. I actually can go quite a long distance. South, southeast, I'm fine. But due to mountainous terrain in Athens, it shows me that my radio horizon is impeded in those directions. I mean, think about the calculations that are going on with the software, that it knows the topography of the area, and from a cartographical perspective, it knows based on my location and the elevation that I presented the software, where I'm at, say, 20 meters above sea level, it knows what my radio horizon is. And I can go back and I can see the other gentleman right here, what his radio horizon is in Crete. Just click on radio horizon, and I can calculate it. And that's very helpful. So calculate the radio horizon for a person sitting in Crete. So if there are mountains nearby, obviously that would impact his radio horizon, which there apparently are. Southeast, he's got the mountains. So there's the radio horizon. You can see that because he's along the beach, in this case, based upon the QTH or the position I gave being at sea level, he cannot see at all to his east. And this is a theoretical location, but you can understand that this is drawing the radio horizon. So this software, AirScout, can draw the radio horizon for a specific location. And it's showing you that obviously there is something that is blocking to everything to the east for that location. Obviously, I just picked it randomly, and apparently I picked it at sea level, so there must be a mountain to the east of that location. That's why the radio horizon for that individual is blocked, and also the mountains to the south. You can see how the radio horizon goes up until the point where it hits a mountain, because there are mountains in Crete. But wherever there's oceans, he seems to do pretty fine. But he's being blocked to his east, and he's being blocked to his southwest. But west, he's fine, and that shows you his radio horizon. So back to this. Here we go with the software now. It's obviously allowing us to see between 2 points, you just have to hit start again, click on the start button, and it's going to draw that line and put those aircraft that we got from the ADSB data. And we can actually see the ADSB data still being updated constantly. It's being received. Here's the ADSB data. Look at the stream of aircraft coming out of Turkey. And that's coming from the ADSB data that we've got from the SDR Play box and its controlling software. And this is the virtual radar again. This is the virtual radar server, powered virtual radar. That virtual radar server is what gives us. That's what gives us again the screen that allows us to see all the aircraft. That comes from virtual radar server, which is taking the ADSB information and decoding information from the SDR receiver, the SDR Play receiver, and the software, which is once again the SDR Uno software with the ADSB plugin. That's that.